Okay, so here's what Jim Propp was writing about on his blog, and it relates to the golden rectangle. So we had some squares, right, in our spiral, and we had some smaller rectangles in the spiral, and then we just kept making a spiral by adding squares on the sides, and it went around and around and around and made a big spiral. And for this to be a golden rectangle, the ratios of basically the rectangles have to be similar. So the big rectangle and the small rectangle here. You see those two?
Yeah.
Do you know what it means to be similar?
They have one same side length.
Not quite. What are two things? Forget a mathematical definition of similar. What are two things that you think are similar?
Well, like an oak leaf and a maple leaf.
Ah, okay. An oak leaf and a maple leaf are kind of similar to each other.
They have one characteristic in common.
Okay. So that idea sort of extends into geometry, and it can be made a little bit more precise. Do you know what it means to be similar?
It means that the side lengths have the same ratio to each other.
Ah, okay. So the side lengths are in the same ratio. Now, that's just a definition.
Yeah.
Okay, so we're going to say these rectangles are similar if the side lengths are in the same ratio. So the long side of this rectangle is A plus B, and the short side is
A.
A. So A plus B over A equals, what's on the smaller rectangle, what's the long side length? Can you tell me?
It's A.
A. And what's the short side length?
B.
B. Okay, so we're going to call this a golden rectangle if the big rectangle is similar to the small rectangle, and that means that the side lengths, A plus B divided by A, would have to be the same as A over B. Okay?
Yeah.
All right. So, the question is, can we ever find a golden rectangle, like you guys were making, whose side lengths are integers? So A and B are integers. And that's the question that Jim Propp was talking about in his blog, and that's the question that you accidentally kind of led us into when you said these were, the rectangles we were studying with our Zoom set were approximations.
Yeah.
They were never exactly the golden rectangles. We're going to see if we can understand why that's true, why they're never quite exactly the golden ratio. Okay?
Yeah.
All right, so we understand similar?
Yep.
Do you understand the question we're trying to study here?
Like, why is it never the golden ratio?
Why is this never the golden ratio? Okay, because it's a really cool idea, and it relates to our spiral, and we'll see right at the end how it relates to the spiral. Okay?
Okay.